But just give me 5 minutes. We're getting started. Give me 10 minutes. Not only that, but we can actually later just say we all the good stuff. You done? You already moved? Yeah, you know.
Hey, I haven't seen my kid in 2 days.
Oh my God. Alright. So that's important. So just give me 5 minutes and then 15 minutes. Yes.
That's a challenge. You said
Maybe we just bring somewhere else. All right, let's get this started. It's about 4 p.m. Do we have all the students here? All the contestants, participants? We have some public members who joined us. Are you related to any of the students that are here? How did you find out about this event? It's awesome.
A friend of mine pointed it out to me.
Okay.
Yeah.
What do you think about the HCC?
I think it's great. I think it's
Good.
also a lot of innovation.
Cool.
Yeah.
Thanks for being here. So, the Inventathon, this is the part where we have some judges. This is the opportunity for us to thank our sponsors. Some of our sponsors have given us the past 48 hours, not seeing their kids. And so we need to be mindful of and also thankful for them. So I really just want to give the opportunity to thank Fab Lab Houston. Brent, if you don't mind, just share a little bit about what Fab Lab does. This event did not happen, almost didn't happen until Brent came in and said, you know what, I have got a solution for you. So Brent, tell us what you do.
Yeah, so I just want to say congratulations to all of you because 2 days, what, 8 hours, 10 hours, maybe you guys worked all night, I don't know. But regardless, 48 hours to come up with an idea and even make a presentation is challenging, but to come up with an idea, make a prototype, iterate, and then explain your idea is even more challenging. And in addition to the mobile lab, I get to work with adults and students of all ages in a big stationary lab with even more equipment. And I see them come through there and have the same challenges that you guys have, regardless of if they're 12 or 48 or 62 retired engineer. It's a challenge to come with an idea and then prototype and do something that potentially is an original thought, because nobody can hold your hand and walk you and tell you how to do it. You got to figure it out and break it down into steps, and I saw that happen with all the teams that I got to work with. So thank you guys for giving up your weekend, because what, you go back to school on? Tomorrow? Yeah. So you're doing some, yeah. Yeah, some real work, and I hope you will tell your teachers all the stuff that you learned here. I know I learned some things, and that's part of why I like doing what I do, because I get to learn alongside people that come to me and say, can you do this? And I'm like, let's see, we got to figure out if we can do it, because I've never done it before. So thank you again. It was a blast, and I look forward to seeing
So
who
every
gets
time
surprised.
on 59 or I-10 or whatever, whenever you see the big Fab Lab mobile truck
Yeah.
driving it, so
So stay out of my way.
Wow, thank you so much.
Yeah, thank you.
inspiration for day one, and then also a workshop, which really helped us see how we could take, in fact, I'm going to let you talk about it, but how we could take technology and combine it to our challenge. So
Yeah, so, man, this weekend just kind of went by real fast. My name is Inventathon, and I started a nonprofit called Alequa. And what we do is we take a water purification technology and we open it up to students and citizen scientists and educators to participate in actually advancing the technology in one way or another, collaboratively. We see it as a great vehicle to not only advance learning more about this DIY water purification process, but also a way for it to be a vehicle for education, whether it be like STEM, coding, 3D printing. We saw a lot of 3D printing today, or chemistry. There's a lot of directions that it's gone, and it's very, it's driven by the students and the educators. So today was amazing. It was the first hackathon we've ever gone to. I want to thank Robbie and thank HCC. This was an exciting time. Yeah.
want to show a picture video?
Sure.
So Ryan also is on the journey, so I want to also showcase and highlight his work, because not only did you provide the inspiration, but also you showed us passion you have for this project, which is great for us educators to really see somebody spending so much time around this effort. And we'll show a quick video. Our audio stopped working thanks to Iggy. He stopped it. We're making it work. Yeah, so what I'm going to do is I'll run the audio from my laptop, but then I'll run the projector with the presentation. So, to make water,
So I wasn't always this water guy. Yeah, that's me. Protesting, traveling, finding himself. I couldn't find much old footage of myself. Back then I was always behind the camera. See, I was a filmmaker, and I found an epic story yet to be told. A story where you could play the hero, and possibly save the world from its water issues. I had this crazy idea, but I had no idea what I was getting myself into.
good job.
My name is Ryan Beltran. I'm the founder of a nonprofit that nobody can pronounce, Alequa. Alequa. This whole story was about a water process that I believed could make a global impact. But then I realized it was going to take a global effort to get it there. So we took the process and bottled it up, literally. We designed a kit that you can make yourself that runs the electric coagulation process. Studies have shown the ability to kill bacteria and even remove heavy metals such as arsenic and lead. And we created the Make Water program, where we challenge you to collaboratively improve, tweak, edit, research, and develop these kits. And with your help, we can empower communities to build and deploy better water systems, all while learning about robotics, coding, 3D printing, and STEM-related fields. And as a community, we not only share our data, but we share our stories.
Greetings, Alequa Make Water students. Welcome to Antarctica.
We're here in outskirts of Medellin. We're with the community that has been displaced by violence.
Now ain't no more probably talking about the violence that's going on.
Yeah.
It's more about the water. But then now the water's getting swept under the rug. What's gonna be the next topic up?
So every season, our kit gets better because of your input. And you can look back and say you helped be a part of this. Oh yeah, and the program is free. All you need is a kit. And we're crowdsourcing contributions so we can give away kits for free as well. So we teach the program through episodes on our YouTube channel. So you can participate from anywhere. So subscribe, turn on notifications, and you won't miss a thing. I don't know if it's gonna pan out. I don't know if it's gonna work. A big part of it isn't up to me. It's up to you. But at least I'm giving it a shot. Now do me a favor. Open whatever calendar app you use. Pick a day 5 years from now. And set a reminder with the following question. You had the chance to play the hero. Did you take it?
Awesome. So good job.
So, thank you.
I want to see that jar. So this is,
It took 4 years to get to this point, and a lot of like circuit boards breaking and things not working, but students and educators just kept, like, especially the first year students, like, had it way harder. But they kept persevering, and now we got to a point where it is shippable, that we can ship to people. So the idea is so that we understand more about the technology, and we want, to empower people to feel good about doing something, and they're also learning at the same time. So, yeah, thank you so
so
much.
awesome. And most keynotes, they come for 2 hours, they talk, and in the past Inventathons, they leave. Ryan hasn't left in 2 days, so thank you for staying in Houston. He's from San Antonio, so to give up your weekend, but then also be away from home, we appreciate you providing our inspiration and the workshop. So thank you so much. All right, so David Regenbaum was our inspiration for day 2. He came and he spoke about how to present yourself, that you're always pitching. And he also told us to be concise, simple, and he said KISS, which is keep it short and simple. And he gave us some tips about presentations. He told us that a great product, if it has terrible marketing, doesn't work. Or a terrible product with great marketing, like the Pet Rock, it could work, but then it's not sustainable, it doesn't last forever. It eventually dies out. So it's the balance of both. A great product, great idea, great concept, but a great marketing, great presentation, and a great pitch. So David Regenbaum is the HCC Foundation board president. So I know he's not here, but the live streams. We want to thank David Regenbaum for coming Saturday morning and giving us his inspiration about pitching. So thank you, David. Camera live stream for him. All right. On top of that, we had mentors who worked with the students on and off. Some of them still here, some of them left. But obviously Brent and Roland. Roland's here. Roland came and left? Roland Fields?
He's still working.
Yeah, I saw him. All right, so Roland Fields and Brent both helped with the fabrication and the making, the 3D printing. Those experts there also helped with that process. Brandon, Deepal, Mohammed, Ryan, all of them are our experts. They come in and they help our students with their concepts. They all have their own unique talents and skills. My ask from the public was here. If you've got a skill, next time please become a mentor for us and volunteer your time to work with these student projects. So thank you, mentors. And I'm missing a few, so that's not a full list. Our judges. So our judges today, Dr. Meyer Donova, who's the executive financer and producer of this event, the Chief Entrepreneurial Officer at Houston Community College. So Maya, thank you for being here. Sunil Pangarkar. I got it right?
Yep.
Thank you, sir. He is a managing director of MTech and MTech, but also a Thai Houston charter member.
Yep.
And that's our connection. Thanks for being here. So it's a private investment or venture capital?
Yeah.
Are you investing in any of the ideas you've heard so far?
Well, I might.
You might. Okay. All right. Y'all heard. Ask him for money.
The reason is because of the money. Because of the water side of things.
Because of the water side of things, absolutely. Thank you so much for being here. You're giving up your Sunday weekend, so it's evening. So thank you so much. Grace Rodriguez, with the CEO of Impact Hub Houston. So Grace, thank you for judging. And then Grace also has been part of this program. She ran a Climathon about a week ago, where this was around the same theme. That focus was more professionals. This is more students. She does amazing work in the city to really, what's your LinkedIn tagline that says, help good doers do good, or greater.
Yeah, help do-gooders do greater.
Help good doers do greater. So Grace, if you want to do more good, meet Grace. She can help you. And then Neil Murthy, you've changed a lot of hats. So this one, chairman of Haven Holdings. Is it still legit or?
Oh, yeah.
All right. But you've got a game board, and I've recently heard you're doing something else with, what was it, Coco? What's?
That's past, that's years ago.
Okay, you were another venture you've had.
I've had a lot of pictures.
All right, wonderful. So he's a great guy to talk to, and also a faculty member for U of H for teaching entrepreneurship. So if you're considering U of H down the line, meet your faculty here now. So thank you so much
Thanks for having us.
for helping. So I'm not going to go dwell into this too much, but of course, without the space, the food, the mentoring help, the equipment and the resources, and even the volunteers, our community college international students who have volunteered, their time to help us with the registration, all of those folks, even Stafford TV when they recorded all the programs. We appreciate y'all, so thank you so much. And now comes the time when we talk about the projects. So we've got 8 projects submitted. I'm getting to it, okay, so here we are. So we have 8 projects that came out of the Inventathon. Mind you that these projects did not exist 48 hours ago. These were all concepts. These were all ideas and concepts created yesterday morning. Students did not have this branding down. Students did not have the description of their ideas down until we announced the challenges around 11:30 a.m. After the inspiration, we gave out the challenges, and then they were off. They had experts and resources to go and build it forward. Some of the students did not have teams. They made their own teams. So they bonded over food and some music. And last but not least, not all of them had the background or the awareness of the issues. So they went, they researched, they Googled, and they found out what they needed, and they created this project. So given that it's created within such a short time frame, I would like to take this opportunity to give all the students that were here for the 2 days a certificate of completion for going through this whole effort. So what I would like to do is, if I could get some help, Kimberly, let's pass this out. Can you help me just pass this out? And we can do this in 2 ways. You call half of them, I'll call the other half here, and we'll award. And then Maya, if I can have you here, we'll take a photo with you, the student, giving the student. We should do the completion first, because then after the awards, everyone's gone. I want to make sure we recognize everyone for being here.
Do you want, Robbie, do you want one of us to help you with that?
Sure,
And then you
please.
can take the photos?
Yes, please. So it'll be much easier if we give out the completion awards now. You guys agree?
Yeah.
All right.
I'll take those.
So, if you could start calling, and then we have 2 sides. So call their names, let them come in.
Get us started, sir.
Okay. All right. You want to do it again?
This is like, and the award goes to.
Okay. We'll go with Ismail Rogers. Is that right? Is that correct?
Right. He's here. Oh, there's 2 of them.
Oh, sorry. Okay.
Hi, I'll get in the phone. Yes. All right, cool, thank you. All right. So, if you don't win, you walk away with the completion, so be happy with it. And we just call them out so they can line up.
Yeah, that's what I was thinking. So,
Okay,
right?
we'll just go back and forth.
Yeah, that's fine.
They're all here, so just call the next name, we can line them up. Great, thank you.
You can still go. We'll finish that side.
Just go faster, just go fast.
Okay. Go ahead. Jala Mohammed.
Imagine when the chancellor does this for 1,000
Jala
students.
Mohammed, right there.
They're like lined up.
There you go.
That's what I mean. Line them up. Line them up.
All right, come on
Get
down.
them lined up.
Jalen Smith. We just need to line up here, folks.
Yeah, just start lining up.
Okay.
Thank you.
Congratulations.
Just call out their names and then let them start.
Jalen? Okay, there we are.
Joshua Iglesias.
Okay, let's get a picture.
Why don't you hold on to that? I'll give it to you.
All right, Amy.
Hey.
All right. I now know her as the person who leaves her U.S. history books. All right.
You're so comfortable.
All right.
All right.
Is that you, Kareem? Kareem?
Thank you.
All right, Kareem.
All right.
Here, Kareem Muhammad.
I do.
Kevin Sony.
And smile.
Kevin, is that you? Okay, great.
There we go.
Get up. Bella Shu. Right. You're
Kevin?
Kevin. Right.
Lauren Ansel. Lauren Ansel.
You're now known as the guy who asks us for change.
Is there a Lauren Ansel?
Oh, she didn't come today.
Okay, all right, we'll put this over here.
Yeah, we have to read. Awesome. So,
Nahom Mulujeta.
Nahom? Or Nahom? Mulujeta?
You're getting a certificate.
Okay.
no?
Neil Ayler.
Neil, come on.
Here we go.
Yeah, dude.
Peter Shui.
Your jawline. Come on, jawline.
Peter Schway.
You,
Oh, I think it's Peter. Peter?
you use that to get your 50 points extra credit from your teacher's class.
Yes.
There you go.
This is Shu? Yeah. Shu, okay, sorry.
Peter?
Prasad Single. Single. Sorry. Prasad Single.
Great.
All right. This is great. We're moving.
Almost there. Hey, you gotta take a picture. Just wait here.
All right.
Good.
Dhruv Srivastava.
Come on.
Dhruv Srivastava. Yeah, the guy with the language. Come on.
Rohan Perkins.
Thank you.
Dhruv Srivastava. No.
Right here. All right.
Sarah Abbasi.
No, is there a Rossi not here?
Erika
There
Miller.
you are, Robbie.
I couldn't pronounce it. I just know the first name.
Samuel Yuan.
But see, everybody knew that, but they never get to.
Ethan Smith.
Good job.
David Hawk.
There we go. Cool. All right, we're done. Oh, no, we got one more.
Thank you.
Got it?
Zain Ahmed. Zain.
Okay. All right. I think we'll just call these out one more time. Just in case.
Hey.
I actually have, if you can see
Robbie, they're trying to get
I need take these out, and I have 8 units that need by what?
Oh.
There are 3 vanilla folders behind you, right there on that? Yeah. If I could get those here, Neil, those are 3 certificates that actually.
Okay, no problem. I just want to make sure that these people aren't.
Yeah, I'll take care of that. We have this one for him. We have this for him.
Here, I'll do it here. Let's table this one here.
Okay, Joshua. Let's do it. I'll give it to him. He can put it in there. We'll give you the phone and put it in there.
We'll do it later.
Come on.
We're just gonna put them in here.
Oh, which one are we missing?
They're just putting it in.
Is this Elijah?
Yeah.
Yeah.
Okay, there we go.
You don't like it? I like it.
Oh, sorry. I don't know who's who, so.
No certificate. Don't hold on somebody else's.
Elijah, there you go.
There you go. This, if you don't mind.
Let me see it. We're gonna have him take his picture. I see it on your laptop.
Okay, folks, we got three remaining sectors. You're probably not here. We go. Sarah, Abasi, not here. Nahom, or Nahom, Mulu Jetta. Does anybody know if Nahom, Mulu Jetta is here? No? And then Lauren is here. Okay, awesome. Great, guys, thanks.
All right, so thanks for allowing us to do that. It's usually hard for me to keep anybody here on a Sunday after the presentations, and then it becomes really hard for me to track you all down to give you all your certificates. So this time I got smart about it. I gave them out first, so now you have them, and we don't have to worry about me tracking you all down. Join us, please. Just have a seat, join us. Come on in. All right, so if I could get the teams here, in this order, we'll go ahead and get, so the team one's going to be Project Green Box, team 2 will be Water Generator, team 3 will be the River Roomba, team 4 will be Car Carbon Conciser. So if you see your name here, go ahead and get your projects. If you really need, make sure that your projects are mobile. I have a table there. You guys know how to do this, self-organize, get yourself a table, get your projects on here. And if your project has water and electricity, then leave it out. Just do the presentation up here, okay?
So when they have 5 minutes or so to get started?
I'm gonna give them 3 minutes to bring everything that they need. And then if you know the order, 3 minutes to get set up, okay? Fair enough?
Yes. Okay, you guys go ahead and get your projects and
So
we'll
go
get
ahead and get your
started.
projects. So the first 4, get the team 5, 6, and 7. Y'all can kind of hang around here so we don't crowd up the hallway.
Which one was team 8, by the way?
1, 2, 3, 4, right there in that order.
Could you show us team 8?
Oh, sure. Let them do it. All right, do you want me to? I can help you.
Are they able to submit?
I don't see them in the list.
I understand that. Are they able to resubmit?
Hey, Angela.
To get it in the document.
Could you remind us again? We don't have anything else today. We can't do any clarifying questions.
So, if you have questions, go for it. But,
I don't want to delve into anything. I just like if we misunderstood something or something.
yes.
Clarify.
Yeah, if that's going to affect how you grade,
Yeah. Okay.
if it makes no difference to the grading, then
That's all.
There's not one of them water here right here.
the impact stay or you don't see a way to generate money.
It has to have an outdated quiet. They don't have to start to get
And then schools are not going to turn businesses anytime soon. They may not have any problems. Anything?
What is completeness and originality? That seems okay, except that the first one is ideal. I'm wondering if this is.
He scored 8 out of 8.
Oh. Hey, Robbie,
Yeah.
can you just clarify for us what completeness and originality means?
So if the project is what they intended to create, if the prototype is complete, then it's complete. If they made it, we do have students they have still just concept. They try to do
Great
something,
idea,
never
but
finish.
they haven't finished.
And never actually prototype and make something. Sure. Just move the award here. Move the
I
award
think
here.
that this is complete. I think it's complete.
I'll get the third one. Oh. Hold it by the base. I figured that out.
You hit save. Then it's asking you to enter the number, right?
Getting something.
Part 2.
Mr. Riley?
Then your internet. Yeah, can you help them make submissions? See? If they have submitted this week. Yeah, the internet keeps going out on that laptop. You can 3 hour drive. Yeah, already.
Are you heading back now?
No, he's gonna watch and take off. But you have to get your jars together. You guys want to move the table up? I can move the table up.
Probably be able to get it.
We may have a nice project. We're trying to submit.
But that will actually be number 9?
If we figure out why it's not showing up. So when you hit save, then there's part 2, which is actually making the submission.
I really like to look at Yeah, that's fine. Are you generally in San Antonio? Okay, like how much time do you spend in San Antonio? How much time do you spend in San Antonio? I mean, you do like 50% of the time? I got an Austin.
automatic. You guys will be here. Yeah, they can fit. They can fit, but then if they're not in there,
Well,
it's a different.
if they want to start now, if you want to start them now, we'll take the notes here, and then we'll just transfer those. It's just a little rate. It's like not numerical rate, we're not writing cash, so.
So if the judges are cool, I'm okay. All right,
You guys ready? You don't think you're ready, are you ready?
all right, so everybody,
All right, there you go.
yeah, I see. All right, I'm gonna add it up officially to the judges. All right, so judges. Wait, you got one. Did one of y'all sneak in an entry when I was home? Or update? No, those are.
1, 2, 3, 4, 5, 6.
7, 8, 9. 9. Okay, we're 9.
Yep.
We're at 9. All right, so no, we updated it. Okay. Okay.
But we're gonna put, just be clear, are we gonna put that last?
Uh,
Octave core, air evolution? Oh, okay. Okay.
yeah, so let's not change it. Let's go with
So,
Project Green Box. You guys ready?
Project Green Box.
All right. Kimberly, get your team in here, and then let's get everybody quiet up. Load up your presentation. You guys have 3 minutes. I'm gonna actually get Google to give me the when you hear the beeping here, that means you're overtime and this ended.
Practice from 3 to 5 minutes per the instructions. I'd like them to have the 5 minutes if necessary.
In the introduction. I'm gonna set the timer for 3 minutes, and then if they go for 5 minutes, no Q&A, judges. Okay? If they use up their Q&A time, no Q&A.
All right, 5 minutes total.
5 minutes total. Google timer for 3 minutes. And your start time.
There's nothing American loves more than a fat, juicy steak. That much we can all agree. However, for the earth, that fat steak is nothing but a joke. It's slowly but surely bleeding the earth out of the life that it has. The fact is this. America has a dependence on the meat industry. According to the North American Meat Institute, the U.S. produces 100 billion tons of meat yearly, the cost of which is insurmountable, with the meat industry being solely at fault for 13 to 18% of the worldwide carbon footprint. The alternative is easy. We should simply grow more fruits and vegetables. When we grow more fruits and vegetables, we see a general reduction of the carbon footprint, a decrease in the meat industry, which will thus yield a decrease in greenhouse gas production in general, and a decrease in the meat industry-related trucking. And of course, gardening benefits the gardener, allowing them to reap what they sow, quite literally. But with so many benefits, why haven't we seen more American citizens start to garden for themselves? Because gardening is hard, and even with proper tools, gardening has many unforeseen pitfalls and difficulties, making it even more unappealing. This is why we've set out to provide a product that makes gardening more accessible and convenient to the average American. Introducing Project Green Box.
The Green Box is a semi-automated gardening box that has sensors for soil pH, light, soil moisture levels, and temperature. These are the 4 most important factors to ensure the life and growth of plants. It monitors the plant's environment, and it uses a companion app that tells you exactly when you need to harvest and when you need to water your plant to ensure maximum growth. It does this through push notifications. It alerts you instantly to critical action when it needs to be taken, such as when levels of light or soil acidity have gone too high or too low, making your plant die. Furthermore, this app records the information and gathers it in graphs to show you the trends on an hourly, weekly, and monthly scale, allowing you to see the trends of what works and what doesn't with your plant growth.
go ahead and plus what's the next one? Just go next.
Just go next.
Just talk about that.
Oh, well, that's like the entire product right there. Those are okay. As much as you can. Okay.
Go for it.
Okay. So, our app is cross-platform, which allows it to be accessed to everybody on multiple platforms, allowing it to reach the maximum number of people. Here it shows when it's going to water, and watering in 2 days, and here it shows you that 60% harvested, meaning that, 60% harvested. Our video would show you the multiple graphs, as well as alerts to critical things, but apparently our video is not working. Now onto the physical box. Okay. The physical box.
The Q&A.
Yes. The physical box is this. This is a scale model. The actual one would be a regular gardening plot, 8 by 2, a raised bed about 1 foot, with 1 foot in depth for soil and roots to grow. It would house electronics in this compartment here, such as batteries and a Arduino. In here, it would house the dirt, the plant, and then in each of these corners, a sensor. One each pertaining to temperature, light, pH, and humidity. These sensors go into the app that he's developed and tell you what you need to do.
Okay. Keep going. Thank you. So, judges, they do have a video, which in the intro,
Yeah, we got it.
if you want to ask to see the video, I can load it up, and then you go ahead and give me permission to do that.
Okay. I apologize, but that's like our entire app. Okay.
Do you also have plans to make smaller versions? Because I live in an apartment, right, so I don't have a plan.
That's very achievable with this because the circuitry itself isn't that large. It's only the box as a whole that's big, so it's very easily achievable.
What's the cost?
The cost is, if I remember correctly, $203.09. And that includes sale tax.
For what size?
For the 8 by 2 by 1.
Any other questions, comments, feedback? Anyone interested in watching the video?
I mean, I'd love to see the video for the time.
Okay. Got 15 seconds, so here goes.
All right, there we go.
So we've
Okay,
got-
okay.
Oh, no. All right, so, here's the
Oh, here, okay. This one.
7 seconds on this one. Play.
Well, that's anticlimactic.
Bummer.
Could I show them on my phone? It's playing right here.
Okay, show the judges.
Okay.
And then team 2, let's get the next team up here.
So this is a healthy plant. And as it scrolls,
Water generator. If I could get the water generator team up here.
weekly and monthly. And you can see where to measure the soil acidity, the soil moisture level, as well as the temperature and the light level. There's another one that shows you critical. Would you like to see the other one?
You started the video. What have you done?
Which allows you to see the, which allows you to measure the series and the critical indicators for when you take action. Like, for example, my other example, which wasn't able to be played, the light level dropping very low. Assuming the low and your plants would die.
Do we need to take some permission or anything? Like,
Unless you let the app would notify them.
the PDF?
So you developed like a bare bones app for this?
Did I give it a roll? They started to call.
No, we didn't use the sensors.
It's part of the main, so I often say by failing we learn a lot more. So failure should be celebrated. So you guys haven't failed in staying in 5 minutes, you just learned a lesson. Use that to your advantage for future. Let me just sneak behind you there. All right, our team 2 water generator. I'm gonna put the 5-minute timer on here. When the beeping goes on, we're gonna call it. I will give you a warning that it's 3 minutes. If you want the judges to give any feedback or ask questions, stay within 3 minutes. But otherwise, if you use up all 5 minutes, then we're going to ask the judges to just rate them without questions. Okay? So 5 minutes. Guys are good to go.
How's everyone doing today? Today we are here to showcase an idea that has changed the world very immersively. We are here to present to you the water generator.
Is it right? Nice. You clicking?
Yeah.
Click down.
Okay.
Give it a second. Click down. Okay, how about this? Look at me and I'll forward it for you.
Okay. What is climate change? Climate change is a change in a global or basically in the environment of how things are. So for example, pollution is a source or a cause of climate change.
Nothing.
Okay, what are one of the causes of climate change? Well, one of the main causes of climate change, especially in this state alone, are the factories, the amount of pollution that's expelled up into the atmosphere, which can cause a greenhouse effect. That would be natural gases or coal.
So our objective today is to basically, like I said, showcase you our water generator. Now the water generator itself is an alternative power source instead of using fossil fuel and coal that we use in factories today. So you all see factories and they release black smoke. Instead, we will be using water or the steam from the water to power the generator and basically reduce the amount of pollution that happens in Houston. So the water generator, as I stated, is a generator that creates energy with the use of water. It is reusable and it does the job of multitask. As well as creating energy, it also filters the water that we boil or that we filter in our chamber or tank.
How does it work? We'll have the, as he stated before, we have the heater under the container, which is just a pool of water. So this heater basically creates steam instead of smoke. And it is sent to the other side of this box, which causes the power. So as you can see, there's a turbine right here, as if it's a combination of hydroelectricity and wind power in one chamber.
Now the amount of water we could use would basically be around the same amount in a regular water tank. So we would need about over 100,000 regular or bottle jugs, gallons basically. And that is our presentation. Thank you. Questions?
All right, you have 2 minutes, judges. They stayed in their minutes.
What powers the heater?
What powers the heater? Basically, it could be any heater, but fire.
So you're gonna use wood, like burn wood to fuel the heater?
I can answer that. The heater isn't like wood, it's more like a metal conductor.
I understand, so, but something still has to provide electricity for the heater to work, right? Or energy for the heater to work. So how do you, where does that come from? Because that would offset the gain from the steam.
Well, we can use a process called internal convection.
Something still has to power that though, right? Electricity? So where does the electricity come from? Because, there's this whole pipeline of energy creation, right? So what are you still burning basically, or what is still fueling the heat creation to heat up the water? It's just something to consider.
Thank you for the suggestion.
So, just expanding on that, like in traditional, like steam engines, like on old trains and things like this, they would typically use something like coal, and burn coal to be able to then heat up the water, and then they would use a mechanism that's similar to what you're talking about here, something like that. But you would still have to use that some fossil fuel or some other mechanism for like actually heating that. So this is something to consider.
All right, time.
Great, thanks.
Thank you.
All right, team 3, River Roomba. Let's get y'all here set up. Team 4, get ready. Carbon Consuxer. Y'all make sure y'all guys are ready. So if I click here, there's a link here. You want to go to it? What do you want to do? I can hand over the controls to you. Ready? Just click through. Here's the clicker. And then when you want to do the website, just come over and you can do it. All right, so are we ready?
Yep.
You guys ready? Time starts. Go for it.
So we are presenting the River Roomba.
So a major problem today is that there's a lot of trash pollution in our oceans and rivers. But do you know that a significant amount of the pollution in the ocean actually originates from the rivers? So our product here, the River Roomba, will stop the pollution at its source, which is the rivers. So how this works is that these are modulated segments made of like easily produced materials, such as like 3D printed plastic or whatever. And then so these are connected in a segment along the river. And what happens is that as the river current flows, it turns these turbines, which then turn these conveyor belts. And what happens is that the trash floating on the river gets caught in conveyor belts and gets pushed to the sides where it can be easily collected and cleaned away from the river. And since this is easily produced and it's probably cheap to make, it can be made from recycled materials to be even more beneficial to the environment. What this allows is that communities can easily engage its members to crowdsource these things and then make them along different segments of the river to crowdsource more data along how this river's total health is.
And this is just a diagram, so the river's current flows and pushes the trash into the Roomba, which pushes it out for easier collection. And
this thing's also linked to a web app.
so we have our application prototype, which so it shows the status of your device, and then it also shows data on your river, on the river that it's operating in. So the current one, we're operating in the Brazos River, which is nearby, and all those dots on the map show locations where ones are currently operating. And in this, you can see your collection history, and then your total collected. But what's more interesting is eventually you can, over a long period of time, you can map the river health and where segments of trash are like more, the river has more trash and where it has less trash. So as you can see, there's the red segments in the middle are where we need to pay more attention, and we can and try to reduce the trash there by taking outside actions such as like finding like businesses or companies and talking to them. And this can also be used to find the exact source of the trash through this method. So as you can see, for the green to the red dot, there's a long section where it's all red, which means there's a lot of trash. But on the top part, it's like all farmland, so I wouldn't really expect it, like the trash to come from there, and it might come from that highway section that's at the very end. So what we can do is implement a Roomba before the highway to check if the section before the highway is safe from trash, and then we can make sure the highway is causing all the trash. And then we can take further action to like reduce the trash from the highway and other means. And so crowdsourced data from this can be used to find the source of pollution and communities, and it can point communities in the right direction for reducing the source. And the data can also be used for scientific research, and mostly it leads to clean and healthy rivers.
So by reducing the pollution in rivers, we then reduce the pollution in the ocean. So in doing this, we're able to use the river Roomba to identify high areas of pollution and take action to stop these sources from polluting the river in the first place. So what this does is that this thing is a cheap and easy way for communities to stop the problem of pollution at its source. And the special focus of this product is to be available to communities and volunteers who just really
Dallas River or the Houston Bayous where there's lots of traffic. And so that's it.
Judges, you have 50 seconds for your questions.
I don't have so much of a question. I just want to kind of tell you a couple things. First off, I like the idea and I like the name. So this is a system that's referred to as a trash interceptor, and we're starting to see more of these in the world, but there are very few. So the most prominent one is in Baltimore. It's actually called Mr. Trash Wheel. It's got little eyes on it and everything, and so it helps to clean up the harbor in Baltimore. So just something to kind of look into a little bit. Another thing is that you might, something like this. I think I like the idea of like being used on Buffalo Bayou or something like this in Houston. And there's a lot of like wealthy communities in those areas that may, those people might be willing to support what you're doing in some way. So just a thought.
Yeah, we just thought it would be different from those things because we're making it more focused on smaller rivers and local communities.
Yeah,
and we're making
so
it
you have
really
a little
cheap.
niche there, and I think that's really great.
Okay, thank you.
Yeah, good job.
All right. We get the next team, Carbon, Conciser, get set up. Climate Change Central, get ready, you guys are next. Project Pigeon, you guys are next after them. So have your projects ready, get ready to, and then let's make sure we get there. All right. Where's the clicker, guys? Down, we'll advance. Ask the judges when you guys are ready. When you hit down, we'll advance.
Button right here.
Sure. Okay, thank you. Okay, your time starts now.
Hi there, my name is Drew.
And my name is Rashad.
And we created the car carbon conciser.
Of like the C3.
So what is it?
Alright. So the car carbon conciser, aka the C3, is an invention that uses emissions collected from gases in cars, and it turns the emissions into electricity, oxygen, and fossil fuel. It creates more jobs as well and saves the environment from greenhouse gases.
To start off, how does it do it? The electricity is created by the turbine. So we pressurize the pressurized emissions, which we'll explain later how the emission becomes pressurized, goes through the turbine, goes through the turbine, which will then move the motor and then create electricity. You can see the turbine there, and
So function details. So a tank is kept into the car, which collects the gaseous emissions. There are 14 tanks per household, and one gets used up every day. We're hoping the government will issue out trucks to collect tanks out, as well as later all the tanks are going to be sent out to the recycling zone, and the gas canisters attached to the turbine that we can see, and the compressed air, because it's so strong, it's going to spin the turbine, creating electricity.
continuing on, after the gases pass through the turbines, it'll go through to the second part of the recycling plant, which is in this dome. And that includes 3 things. 2 of them are plants, which is the Erisa palm, and the snake plant. These 2 plants are known for their ability to purify the air of benzene, xylene, and toluene, which are the majority or some of the emissions from petroleum and crude oil. They also produce oxygen faster than most other plants, which is good for recycling carbon dioxide and other emissions into oxygen. In the future, we want to add a machine, which is the 3rd part, from a company called Dimensional Energy, which creates methane from carbon dioxide, which is also a greenhouse gas, but it can be used as a fuel in ethanol and petroleum.
Right. So as you can see in the car frame, the gas canister is put in, and it's extremely safe. Like, we were originally thinking about putting it behind the bumper, but in case of casualties such as if another
Not
car-
casualties. He needs to say
So, in future evolution. So, triple C3 would change the future for all gas owners, for all gas car owners. So, keep driving your gas cars, keep using your gas engines, but support C3 so we can bring the future to the present. Also, another big reason for this is even though we support electric cars, is that BP, British Petroleum, states that most of our oil reservoirs have not been found yet or cannot be extracted, and they could double by 2050. Thank you.
All right, judges, you've got a minute and 20 seconds. Do you have questions?
I'm sure you do.
I have a million questions.
Detailed
One question is, how big is this device and where does it fit in and how much can it,
We currently believe that it would take 1 day of driving, not constantly, but say a road trip perhaps. So maybe once every 3 days, one canister every 3 days. And it isn't that big, as you can see here. It fits inside this car. And this is just like free prototype, and doesn't have like some of the wheelbase and all that. Yeah, we hope to, if we get it crowdsourced and crowdfunded, we hope to talk with engineers to help do better design.
Okay. You have a question?
No, it's a very similar question, because how large do you expect the turbine to be and the capture mechanism to be for it to actually exist on a car?
Oh, the turbine machine isn't in the car, it's in the recycling plants.
So how are you getting the gas, the emissions from the car into the thing that's going to turn that into?
Sorry about that. So trucks are going to come every weekend to collect gas cans for neighbors.
But the gas can has to still be on the car to capture its
Instead of
emissions.
going from the exhaust pipes, it goes into the canister.
All right.
How do you compress it? I didn't understand the
Oh,
question.
it will, the
All
car
right, let's
engine
hit the
will
next
push
team
it.
over.
So you're, okay.
All right. Neil, you broke the device. You just got it.
I
You broke the
up to this.
prototype.
I sincerely thought it would turn,
No,
and then I touched it.
you're now committed to funding.
I'll tell you what, I'll fund doing this together.
All right, you guys ready?
Oh.
All right.
I thought it turned, so I was like trying to turn it. I see. Thank you. But I didn't break it.
So if anyone is curious, if they go to inventathon, hcc.devclose.com, all of this information is on there. The photos they've uploaded, the description. So this is what the judges are looking at. So just in case you wanted to look at this stuff later, it's available. They've spent a lot of time putting all this together. So it'll forever live on this website. So it's your digital portfolio of work. You guys have 2 websites. What am I opening?
You want us to look at this?
There's 2 websites.
The drive. You guys know
The drive? Okay.
So we're supposed to zoom in?
Yeah, you can. We'll double.
So this is your PowerPoint. I'm just going to download it, and
Okay, great. Thank you.
the clicker is here. Give me a second. I'll open. I guess I'll open with Google Slides. You guys always give me this challenge at the end. Presentation. Some of them are on OneDrive, some of them are on Google, some of them are on PowerPoint. But you guys help me learn, so it's all right. Okay, your time starts. Is you ready?
Yep.
Grace, you okay? You ready? All right. Start. Go for it.
So a study by Yale in 2019 this year showed that 3 in 10 Americans are not aware of climate change or do not believe that it exists. This is a very concerning informational gap in today, considering the U.S. is one of the highest producers of CO2 and highest contributors to climate change in the world. Our solution for this, Climate Change Central.
Down.
Done. Okay.
Okay, too much.
Sorry. Okay, so our app consists of 2 parts, a visualization section and a tracking section. Our visualization section uses maps, an intuitive UI to show a variety of different sources that may contribute to climate change, such as CO2, predicted water level rise, renewable energy, and deforestation over the years, so users are able to see this over progressions over time. Also, highly innovative is our tracking section of our app, which basically allows for users to input a couple simple questions about their house and square footage and such, and using an AI which is hosted on a GCP server, they're able to get results. They're able to get results about how much CO2 their home is producing every day.
So there's 4 different maps on the app. First starting off from the pollution map. So you can see on the pollution map, we can press and it'll first give the map, and as you see, it's calling an API while it's here, and it'll show you the next year and change in the next year, so it becomes more and more red as the years go on. The next map is we have the water level map, and for this one, if we zoom in on Houston, we can see as we continue to increase the water level, it's predicting how the coastline will flood and how water will encroach on the land. Next, we have a reforestation map. I'll skip for now, and then we also have the renewability map, which it shows countries from starting from 1965 how quickly they adopted renewable energy. So as we continue to increase, we can see which countries are starting to get ahead in renewable energy, which ones are falling behind.
Now, one of the most core parts of our app again is that AI that I was talking about, which is again visualized in these visible graphs over here. So basically, it takes in temperature and again a couple of questions from the user, and then posted on a server on the cloud. It returns results about pollution every day based off of temperature data, which is again taken off of open weather map APIs and other data sources. Now, what's very interesting about this AI is that it's not necessarily solely applicable for this app itself. It's also applicable for a variety of other sources using the ASHRAE dataset. Which basically ASHRAE dataset is able to predict things like energy consumption of a variety of different buildings, including industrial buildings, educational buildings, and residential buildings. In addition to the residential buildings shown over here in this particular purpose. This is highly valuable. And can be applied in a variety of locations. Now, for our data, obviously at the core of our app, we use a variety of sources, APIs, open data sources, web scraping, and embedded web views.
Yeah, so for the maps, we have both the emission map as well as the pollution map. We pull from APIs and also credible data sets that are open and freely usable, and so that we pull these data and we can process it and display it on the maps that we created ourselves.
Finally, going back to the how do we actually do it? We used a combination of the K-fold and LGBM algorithms with an endpoint of 1.12 root mean square error, which is 0.09 above the lowest score ever recorded on this particular data set, highly accurate. Now I'll turn you guys over to any questions you have.
45 seconds, judges. I have more something to say. I think it's interesting. You started off your first slide. What I was getting back to this, but why did we build this app? Something like that, right? What is the purpose of this app? And you started off by saying that it was there were a lot of people who are uneducated about and who don't believe about climate change and things like this, right? I don't know that your app was going to help those people. Is that the intent?
The intent is not necessarily to make climate change non-believers into climate change believers. It's more to bring awareness about climate change and to sort of inform those who want more information on climate change.
So I think, if I may, I think what you've got here is the seed of something really good, but I think you need to be, I'm going to focus a little bit on the negative, not so much on the positives, there are a lot of positives, but maybe think about turning this into some sort of like game, or something like that. Building it around, like, I mean, you're partnering with Google, is that correct? Partnering with Google, or you're just putting it on Google Maps?
Using their
I think
APIs.
Google might be interested in that, or Alphabet rather, through Niantic. They might be interested in something like this to build out an application that would be a gamification, but pulling in real-time data and helping people to understand it, but in a fun and entertaining way. I mean, climate change isn't fun and entertaining, but you can make the engagement with the data fun and entertaining. Does that make sense? So maybe that's something to just think about.
Gamification platform, yeah.
All right, guys, our time is up. Let's get the next team up here. All the programming and coding you guys did, you guys uploaded on GitHub. So is it open source? All right. So all the work they've done in programming and coding the apps and pulling the APIs together, a lot of the student projects, it's open source. So what we put together in this 24 hours is also made available for anyone to commercialize down the line. Again, this is the talent. So let's get our next team, Project Penguin. Pigeon, my bad.
What's your call?
Penguin. I just read it like quickly.
You just transformed his idea.
You know, there was a time when somebody said take the D out of the Facebook, and that was the $1 billion idea. So.
Why am I up there submitting an idea?
You're arguing, right?
I'm like, I don't, and I also don't, by the way, I know that that's not me, because I didn't even access it until like an hour and a half ago.
All right,
this is why I get blatant for everything.
I know.
Just using my name everywhere.
I know. So you've got 3 GitHubs?
Yeah, so.
And then which one am I looking at? The docs?
Yeah.
Okay.
The GitHub
All right.
shows our, we made an organization, so I linked our organization in both of the repositories, because we have one repository for the code, like the machine learning that we use, and then one for the website.
All right, I got it. Okay, where's the clicker? Oh, there it goes. There you are. Bottom will advance it.
So that's why you thought it was Project Penguin, because the penguin's not there.
Okay, hello. Hope you guys are having a wonderful afternoon today. My name is Bill. I'm Rohan.
And I'm Erica.
And we are Project Pigeon. Let me see if I can make the clicker work.
Bottom.
Oh,
So the problem about our problem with the environment is that there's an increase in greenhouse gases now with all the new technology and all the factories. And so one thing about this is that the atmosphere is getting saturated with all of these gas emissions. Here's the thing: is when all the gas pollution goes up, it's all going to go down somehow. So it has to go somewhere, right? So it goes in the form of rain.
Okay. So introducing Project Pigeon. So our idea was to create something that could predict acid rain, because acid rain is very dangerous. It can cause fish to die, it can cause statues and infrastructure to deteriorate, and that costs a lot of money. So we don't want that. So we created an affordable option to predict acid rain so people can avoid it. And we called it Pigeon because it's the most commonly found bird in areas with factories. So our capabilities. So our project is split into 3 parts. One part will collect the pH of the air, one part will determine the rainfall in a certain amount of time, and one part will predict the location of that rainfall. So, as we mentioned before, this gives ample time for owners, not just big corporations, but small people, to also protect their property from acid rain. And the reason why it's affordable is because it's only built out of commonly found materials. This drone costs $10. This camera costs $10, and the Raspberry Pi also costs $10. So it's very affordable. Alright, so the drones, sorry, not the drone. The machine uses machine learning to predict the rainfall, and overall it trains itself from data that we find online that's completely free, and it just collects everything in files and does algorithms with it. And the camera is what is used to determine the pH of an area. For now, we're using litmus paper, but in the future, we'll move on to pH sensors. It'll increase the price, but it will also increase efficiency. And there's also...
Oh, so for server-client communication, so we were thinking of using something like Raspberry Pi, which is connected to a Linux kernel, such as like Raspbian via SSH or Secure Shell. Very, very simple to set up, very, very cheap to set up. So data is going to be sent via text or normal text files through Python script. So this is relatively very cheap and very quick to make.
So machine learning. So we use a model of recurrent neural networks, specifically the gated recurrence unit, or the GRU. And the reason why recurrent neural networks are good is because they remember previous information, allowing us to make trend-based predictions. And so we use the NOAA dataset, which is a free dataset of weather data in America. Of course, sorting this data was a hassle, but we got it to work. Due to limited access on the data, we only got 73% accuracy, but we're looking for more if we're given access to paid data. Data collection. So we use OpenCV, which is a computer vision library, to find the dominant color of the litmus paper to be able to achieve the pH. So the data cleaning was done algorithmically using Python, and we used an Oracle library to determine wind speeds from the internet.
So the server node communication. So we use a secure shell connection to communicate between the Raspberry Pi, like I talked about previously, and the central server, which is something that can be on any computer since it's a little bit low. It doesn't require that much. So this basically allows for the neural network to receive pH data from the Pi displayed on the website. The litmus paper would be analyzed for the dominant color to determine pH value. So you can see all the way to the right that would be indicated as a dominant color.
So how this works is we measure the pH of the sample of air, and then the user inputs a parameter time. And so time allows us to use the velocities of the jet stream to determine the location of the landing area, and the machine learning basically predicts the level of rainfall.
So for the website, so our machine code outputted all the data in a CSV file. So in order for the backend to technically interpret it, we had to use one library. So we had to convert that CSV file to a JSON file so it could be technically considered as an array. So then the client connected to the web interface would be able to select days in the future, which the website using a JavaScript variable would convert the plain text for Python to array. So the Python code would be then exported to the rain levels as JavaScript variables, which the website would be able to display.
All right, guys, remember David said elevator pitch. This is not the Empire State Elevator. This is a 10-story, 3 minutes was max. So time's up. Judges, we don't have question time.
Okay.
Very technical. Good job. Very passionate. Very good. Again, all the open source code is available on GitHub for the work they've done. Let's get the next team up here. Filter, mash, design. Mash. Mesh. Mash, mish. All right, thank you. Where's the jar?
Well, that's our project.
You left the jar? Okay. All right. PowerPoint. Here's the clicker. You can hit down on the jar. All right, 5 minutes starts now. Oh. Go ahead.
Okay. So I'm Peter, Sue. I'm David, Sue. I'm Andrew Bay. And our project was a filter mesh design. So we went to solve. So we were thinking about Elecwall, the nonprofit company, and their main point was to filter water. And when we used their kit, we noticed that the coffee filter didn't really work effectively. So we decided to make a filter that would effectively filter water.
So our original idea was making a 3-layer filter device which has holes that are finer each level down, but due to some complications of printing and efficiency, we decided to go on with this simple, effective mesh design idea.
So, as David said, it helps filter water but not in the way that you think. Although Elecwa uses a jar, we decided to go with a different approach by using a water bottle. So we use the mesh, we cut it out, and by exerting the force, by squeezing the water bottle, you are able to filter the the coagulations in the water from the bottle, and it filters it so that the dirty part and the clean part of the water will be separated.
Some of the drawbacks that we had experienced was because it was the first time they ever dealt with trying to print out a 3D model of a met or a filter. So our original idea didn't work. So we changed to mesh, and it did work, but the 3D printer provided did not. Didn't have any. Well, it didn't have resolutions that were clear enough to make the holes that we wanted. So the mesh that we made for our model has a particle size of 500 microns, but we plan to make that smaller with a better 3D printer. And my bad. But yeah, and so we made this filter mesh because the coffee filter, you're gonna only use it once since it's paper, and if you wanted to use it multiple times, it wouldn't really work. So we made a filter mesh, and but it didn't really work because oh my bad, I'm so sorry, I'm nervous. So the mesh can be actually cut out into pieces. So like this water bottle. And the point is to just squeeze it and get the water out. And even though it wasn't really perfect, we just hoped that it was like a foundation for other people to go off and make better 3D models of filters. That's it. Thank you.
All right.
You have a minute and 30. Yeah.
Is that bottle
Wanna pass it out?
Has the mesh?
Yeah, it has the mesh.
Oh, can we see that? Okay, great, thanks.
I guess past that, that's the actual mesh, right?
Yeah.
Show that around. And look through it.
You said right now it's 500 microns?
Yes, but we plan to make it smaller if we could have a better nano printer.
What's the material?
I think it's just plastic.
Okay, just a standard
Yeah,
like
for the
printing resin or something like that.
Yeah. Is that it?
I have a comment. So considering some of the solutions that we've seen, sometimes, especially when you're an entrepreneur or inventor, the danger is falling in love with the solution and trying to over-architect, over-engineer, over-tech, a solution, when it could be something more simple. So maybe it's not necessarily 3D printing that we need to look at, but fabrics or what other kinds of materials are there out there that are very good at filtering out particulates. Yeah.
Awesome.
All right,
10 seconds to spare. All right, let's get the next team.
Are you a part of this team?
No. I'm part of none of the teams, but I do care about all the teams. Yeah. Every single one of them, we get a chance to, I get to drill on them, you know? Yes, no, let's do it. This is great. Let's do it. It's an opportunity for them to fail and also grow. Come on, next team. Elecqua water adapter. Where are you guys? Guys ready? Adapter. So this is our second to last, right? We're gonna second to last.
Oh, okay. Oh, there's one more.
Yeah, so them and then one more.
Oh, right.
Yeah, the first one, we'll do that one last.
Okay.
Okay? All right, guys, let me get this ready.
And then after that, I can present my awesome project.
Vegan lunch cross. We gotta.
I've got 5 minutes to come up with an awesome project. Is that what you're saying?
Yes. Here's the clicker, guys. Who's gonna drive it down? Joe? 5 minutes, start now.
Good afternoon, guys. My name is Jaden.
My name is Dylan.
My name is Anthony. My name is Joshua.
And we're the designers of the Electro Water Adapter. Now, the reason why we made and the reason our concept and thought process behind designing this is that we were really inspired by the Elecqua water purification and coagulation system that Ryan developed, and we thought that yes, it is practical, it is nice, and the design is very smart. But we thought that the idea of a mason jar, only being able to use a mason jar, is not really logical, because he wanted to help people who don't have access to fresh water. So what's very readily available in places where it's like below poverty line, examples being like Philippines, Africa, India, places like that. There's a lot of plastic bottles, and they can just pick one off the street, clean it, and use it. It also promotes using plastics and things like that. And yeah, these are just examples of what happens. And basically, plastic bottles contribute for like 80% of like a lot of things that are in the ocean, like plastic-wise. And what's it called? They block the UV rays from going into the water, which helps with the algae, which is like the very, very bottom of the food chain. Very important.
So how does it work? So we have our product over there, the green one. It enables to like clamp onto the water bottle or any water, because it was an accidental find, because at first we didn't think that like it could like open up and clamp in, but then as soon as we cut it, due to help of like some of our mentors, thank you. We found out we can clamp it by stretching it open and clamping it in. And also we added a little container / opening so we can put the Arduino in. And also for our cap, we made it to the point where we could place it on top of the water bottle and it won't move. It would shift slightly, and this process would like help like improve like other the things that it did for the Arduino and stuff like that.
We built our product by designing it in Autodesk Inventor, which is a 3D drawing program. We made it into a 3D model by using one of the 3D printers in the fabrication lab. And the first one was destroyed because the printer messed up, but the second one, we got it. And it fits on the water bottle very good, and it works for its intended purpose.
We ran multiple test trials to try to figure out, what we can improve and how we can make it better. I believe we ran 2 exact trials, and they both functioned pretty well. We did make minor adjustments, and we actually, for the clamp, this attachment, we actually have multiple sizes, larger sizes, but we didn't have the time to print them out, because only being limited to one type of water bottle, it's not really logical or practical, because it's different sizes, because some people might need to purify more water at the same time instead of just one little bottle. And yeah, that's our it's called schematics and stuff.
It's our sketch, multi-view, and all this stuff.
And
Any questions?
All right, you've got a minute and 15 seconds, judges. I'll share while you're thinking, brainstorming. All the software was available by HCC to do the AutoCAD work, the 3D modeling work, Autodesk and Inventor, and you guys used all as part of the process. Some of them touching it for the very first time to model this and print this stuff.
I definitely appreciate all of the skills that so many of the students are learning through this program. But I go back again to over-engineering a solution, right? Because if you're 3D printing, you're also creating more plastic, and you're putting more plastic into an environment. So how do you think of a way of solving the similar kind of problem in a way that where the little pieces, let's say if they break, or people aren't using them anymore, how can they be recycled? How can they not contribute to the problem?
Like I said, we don't have like the technology or the materials, but it could be better if we could have like biodegradable plastic and stuff like that. So in case it does end up in somewhere else, it'll probably dissolve in the dirt and probably like end up safe.
All right. All right, thank you. So. get the next team. I gotta say, all the teams have taught me something. This team has created something very unique. So once you guys get up here, I'm not even gonna try pronouncing. You guys know how to say that. But this is our last team. But make sure that judges get to see what you created. Get some more time. All right, so this was the team we needed to get in the last entry. This is our last team. Here's the clipper, guys. At the bottom, we'll move forward. And am I ready? Okay, well, let's start. The time starts now, guys.
Hi, I'm Elijah Gilstrap.
Hashim Mohammed, Asiel Kaur,
Amal Muhammad,
Ethan Smith,
Joshua Alford.
And together we are OxyCorp.
And today we just wanted to explain to you our project of evolution. So Hashim, let's take the problem.
Well, the problem is greenhouse gases, greenhouse gases, burning waste, and vehicle fuel are slowly destroying our ozone layer,
causing climate
change.
However, we have found a solution from converting greenhouse gases into the liquid form and purifying that, as well as rather than burning waste to destroy it, using the electrolytes and waste as for fuel for cars and rockets. Additionally, we have found an alternative way to combat greenhouse gases with pure gases.
Based off information, our theory is that by pressurizing the atoms together, converting a gas into a liquid, then by purifying it would then prevent the greenhouse gases from becoming our ozone layer. And some facts about our data is that 3 years ago, 91.3% of the world was polluted, and research only states that it's getting worse.
While doing our research, we discovered that greenhouse gases have the worst effect on the ozone layer.
In addition, scientists have discovered a solution for this problem, but have yet to execute it.
However, we, OxyCorp, have found a way to execute this project. Execute this project using our reactor and our filter.
So, as you can see, our project is split into two sides. One is our reactor. What our reactor does is it absorbs all the greenhouse gases found inside of the atmosphere and found inside of the ozone layer. And it brings them inside of one concentrated area. Inside of this area, they are pressurized, the atoms are pressurized and converted into a liquid, as my colleague said. Now, after they are converted into a liquid, we use the electrocoagulation process. This makes sure that the liquids are actually pure. Now for our second part, we have our nuclear factory, and then we have the filter on the top. What the filter does is it actually uses gases like oxygen and hydrogen, and it combats the greenhouse gases. And since the greenhouse gases are not as pure as oxygen and hydrogen as we know, the pure gases will win, and the more helpful toxins will go up into the atmosphere and will actually heal our ozone layer.
So we're going to need a lot of people's help. We have estimated that this project will be about $6 billion minimum, with a maximum of $9 billion. That's like almost $1 trillion. But I'm pretty sure with the world's help, we come together, we can get this done.
In order for this project to work, we need everyone's contribution to this project.
And that concludes our presentation. We are open to any questions related to the project.
We've got 2 minutes. I just want to comment that there's an architect firm out here. Look at those trees. You guys should hire these guys because the realistic nature of the trees they've created. That's pretty neat.
Now, see, it's actually created that we put the trees here. The reason why we put it here is because the goal is we don't want to retire pollution, right? And clearly we can't stop factories. Life is going to keep going. So we have to make the best of the situation. So we have trees around here to show that this will not only save the ozone layer, but it can keep trees alive as well. And it's completely safe.
Judge's question.
How do you collect the greenhouse gases? Have you thought about how does the collection happen?
So Dubai has actually created a vacuum where they have sucked in components from the air. So we're thinking if we were to create that same vacuum but on a higher level, we could get those, we could use that vacuum to suck that gas into the tube and quickly convert that, by compressing the atoms, convert it into a liquid.
And for the factories, as we know, factories create pollution a lot of times because of the smoke that is leading out of it. And that's why the filter is on top of one of the actual smoke spouts. So, like, inside of it, we all know it comes from there. So to stop it before it even reaches the actual atmosphere, we placed a filter right there, and that's where we get the greenhouse system there. And then my colleague stated how we actually capture the greenhouse gases inside of the reactor.
Now, how do we know it's going to convert into a liquid? Well, most of the greenhouse gas contains methane and carbon dioxide, which cannot turn into a solid, but only a liquid. So when we convert it, it will only convert into a liquid, which proves that we can purify it using the coagulation process.
Great job.
All right, thank you. Have a seat, guys. Okay, so while the judges are doing their work, could I have the two teams that presented the water filter or the project for the Alequa Challenge? Ryan, before he takes off for San Antonio, would like to make an announcement for y'all. So the two teams, if y'all just come up here. Ryan, you just come up here too. So the team that did the water filter challenge, the judging is happening. And where's the other team with the two guys that did the, yes, three, my bad. Yeah, three? Okay, they're your kids. What you want to do?
Oxycore.
And Oxycore. You guys as well. Judges, as you're grading.
I wanted to give each of y'all, for including Alequa or Negan, electrocoagulation kit that y'all can have.
Got it? Everybody get one?
Thank you.
Oh, sorry. All right. Did you get your photo? I didn't. Huh? Did we get a photo of him? Like, was that? I'll take some photos. Right? We'll get it to you.
I mean, actually, the photos so big, like, they're driving there.
That's the photo you'll get. All right, so.
Just like, yeah, it's so this is a 1 out of 10 skill.
Yeah, I didn't get there. This is all right, so the judges are scoring. This is your time to network. Make friends, get to know, look, people are thinking about these things. That's important. People have skills. That's important. So find your inspiration, find your skill, network with each other, and we'll announce the first, second, and third highest scorers. They'll walk away with the what we created this morning, the awards for this year's, this semester's Inventathon. We'll give this out as soon as we have your grades. So make friends and then stick around.
No, that's the. That went last.
This is also a great opportunity for you to go clean up your areas because we do need to leave the campus the way we found it. Pack up, get your stuff, and then everybody bring everything here. If you see tables outside in the hall, please pull them back. Ask the grown-up to help you. Clean up the area, leave no trash, throw everything in the trash can. Go to your classroom, clean it up.
Share the photos.
erased her paper on it. No, yeah, of course. And she was here yesterday. What happened? Why didn't you come? If it's already printed. Yeah. But you know what? She's not going to get the cool. You can pick it up. This is what a teacher to get the 30 points per.
No, that's still us. We're coming back. We don't have extra benefits.
Hey, she went to Clemens.
Oh, really?
Yeah.
Yeah, I graduated in 92.
Oh, cool.
Alumni. So you should probably take her number. Because she knows a lot of people. And then when you need her, you could buy them. And just say like, hey, we went to the same high school. How come I can't find?
Is Mr. Steinkamp still there?
No.
Oh, really?
I can't find your.
Really? He was my favorite. He was, he did AP, taught me AP bio.
Is that her? Lauren?
When I was there, that was a long time ago.
Tell her it's $5. Are we good on the grading?
I'm done.
You done?
I think we're all done.
Okay.
He's still putting phrases.
Okay, yeah. Take. All right. It's coming in.
You can't? Oh, that's why it's at a 10. Jesus. Okay. Now.
So as soon as you're done, we could just pull up all the.
You guys can use
Is it a calculator for you on that?
Yes, thanks to y'all doing it on your phones. It's actually giving me a total right now. It was 1, 2, and 3. If you want to see. Yeah, as soon as you throw them the score, then it could go.
Actually, they're pretty consistent. Very cool.
No, well, this is a little longer. No.
Oh, which one?
You sort of well, I mean,
Are you done? Did you get all of them? I'm just gonna refresh. Click on it. Yeah. I can't see it. One more time. Okay,
all right, there we
you
go.
guys agree with that? You guys agree with it?
We have to.
We have to, yeah.
We're the ones that want to score.
Yeah, that's it. I'm not gonna vote. My account was the backup judge in case one of you didn't show up. But thank you for showing up.
Well,
Thank you for showing up.
we have 3 clear winners by overall rating. So.
Alright, so,
Yeah.
if we could start getting the teams back. Hey guys, can you make an announcement that we're.
I'll head out in the hallway now.
Yeah, let's get the. Thank you. Yes, of course. Thank you. So, Mohammed and I worked on the emergency guide for HCC. They just taken his work and printed it. And this is a every time. I've never recognized that contribution. But if you ask the risk management guy.
Can I take this?
Yes, Executive Director for Risk Management. This was our student project. We did all the work to get it out on the website so they showed the WordPress. This was printable. Now we can bring out HCC and put this together and make it easier. This was part of our any other students. Just like we go to Well, this is public input.
Well, they already know?
Yeah, these kids already know.
Oh, okay.
I don't even do, some of them may not even show up. But my point in showing this is there's an opportunity for them. Look, when they go to university and write, they don't just think that. It's a little rush for this is where you go. All right.
I just didn't know they had access.
And then, it's only this is 7 times presenting. Each presenter. So, we have, right, because we, all right, so if you're not here, you don't win. So tell them to come in.
Well, I'm gonna leave now.
What? You already saw the score? All right, so just tell everybody. Just get over here, get in. All right. All right, so we are way over our time. We need to wrap this up. So, thank you. All right, if everybody's here, the drum roll for all the scores, and some of you have already seen it, which is fine. That's how competitions work. The scoreboard is on the hackathon website. I'm just going to open it up. This is how you guys were scored on those projects. And if I can have Climate Change Central, River Roomba, and Project Greenbox at the front here to claim your first, second, and third in a big group photo for getting the top score. You're getting the top score for your projects. So, 3.75 Climate Change Central. Where are you guys? Just take this, Maya, judges, please come up here to take the photo. Remember that if you need to get feedback from the judges, I put their LinkedIn links on the website. So if you see a score you don't like, go bug the judges, right? Ask them why.
Wait, you didn't tell us that before we were judging.
Use this opportunity to ask them why and what and learn from this opportunity. So, I'm gonna turn this off so we can be in the front actually. And then Brendan,
are we gonna be in front of the table?
Yeah, let's all be here. Brendan, if you want to take a good shot of us for first and second, third. Come on, Sina. Do you want to have all of them together? Just one? Yeah, just everybody come. Take your own votes. Number 2, you guys were number 2, right? All right. Just hold it on the bottom. Number 3, let's take that. Yeah. So this is their like time crunch. So I'll be around here. Good job. And got everybody? All right. So just get out.
Thank you for your whole team. Good job, guys.